Hello everyone, in this video I am going to explain the expression of K for zero order reaction as well as the expression of T half for zero order reaction. So please watch the video till the end, you will understand each and every concepts. So let's start, let's consider a a reactant to product. Okay, so when we talk about R to P, where R is what? Reactant, P stands for product. So for zero order reaction, okay, what we can write, a rate is directly proportional to the concentration of reactant to the power 0, yes or no? Or when you remove the proportionality, you have to put a constant, rate is equal to K into 1, anything to the power 0 is what? 1, so we can write R to the power 0 is 1. Okay, when you are removing the proportionality, we have to put a constant K is nothing but a rate constant, K is nothing but a rate constant, or also called as velocity constant. We know that by definition of rate is nothing but a minus dr by dt. What is rate? Minus dr by dt. Okay, this is the definition. By definition, rate is equal to what? Decrease in concentration of reactant with time. So we can equate both equation 1 and 2. So once you equate, we can write from equation 1 and 2. Equation 1 and 2, we can write minus dr by dt is equal to K into 1. Okay, or cross multiply, so minus dr is equal to K into dt. Okay, once you multiply with minus here on both sides, we can write minus become plus, okay, plus become minus, so plus dr is equal to what? Minus K into dt. Now we have to integrate both sides, we have to integrate both sides. Once you integrate both sides, integration of dr is what? Okay, r, whereas K is constants, we can take it out. Integration of dt is what? Integration of dt is what? T. Now what we are doing, whenever T is equal to 0, okay, in the beginning, let's take the concentration of reactant is R naught. Okay, substitute this value. So R is equal to R naught, that is equal to, okay, here one more thing is there, you have to add a constant of integration. Okay, whenever you integrate, okay, integration of dt is nothing but T plus constant of integration, I am writing I. Okay, so here I is also there. So whenever when time is 0, take the concentration of R as R naught. So we can write R naught is equal to what? Minus K into 0 plus I. So we got to know that I is equal to, okay, this into 0 is what? 0 plus I. So I is equal to what? R naught. So we have to substitute the value of I is equal to R naught in this equation, equation 3. Okay, equation 3 you have to remember. Okay, this is the equation 3. Okay, so let's see. Okay, what is equation 3? We got that okay, R naught, I is equal to what? R naught when time is equal to what? 0, and equation 3 is nothing but let's see, equation 3 is nothing but R is equal to minus Kt plus I. Okay, it is R is equal to minus Kt plus I. Now substitute the value of I is equal to R naught in this equation 3. Okay, substitute the value of I in equation 3. So we can write equation 3, R is equal to what? Minus K into T plus, instead of I we have to substitute R naught. So that R naught we can write. Okay, move the left hand side, transpose R, you move to the right hand side, so we can write plus Kt is equal to what? R naught minus R, yes or no? From here we can write K is nothing but R naught minus R divided by T. This is the expression of K. Okay, where R is nothing but final concentration, R naught is nothing but initial concentration, T is the time, and K is the rate constant. Okay, where can make a note, R is nothing but final concentration, okay, R naught is nothing but initial concentration, okay, T is nothing but time, and K is nothing but rate constant. Okay, this derivation may be asked for 3 marks. Okay, let's discuss the graph. Okay, let's discuss the graph. So when we talk about the graph, okay, let's see here graph. Okay, what is the expression? We have the expression R is equal to minus KT plus R naught. So I want the graph between, okay, concentration versus time. Okay, let's see the graph. I am considering this is y axis, and let's say this is x axis. X axis we are considering as time, this is the time, and this is the concentration R. So you can see here this is y is equal to mx plus c. Okay, so here m is nothing but minus k, c is nothing but r naught, that is the intercept, and y is what, r. Okay, so slope is what, negative. You can see slope is minus k, so graph will go like this. Okay, graph is like this. Okay, this is the graph. Okay, so here this is the slope. Slope is nothing but minus k. Slope is nothing but minus k, and this is nothing but intercept, r naught. This here to here is what, intercept, and this axis is, x axis is what, time, and y axis is what, concentration. Okay, so we can compare with the straight line equation. Y is equal to mx plus c. M is minus k, x is t, c is the intercept. Okay, this is the graph, you must remember. Now let's talk about the half life period, okay, of a zero order reaction. Half life period, half life period of a zero order reaction. What is half life or T half? We can say the time duration when the concentration of reactant is reduced to 50%. Okay, that is the T half definition. Okay, so we know that since we know that K is equal to what, R minus, okay, R naught minus R by T. This is the derivation just now we did. Okay, what we learnt, K is nothing but R naught minus R by T. Okay, this is the derivation we learnt. Okay, so when T is T half, okay, or we can write T 50%, what happens to the concentration of reactant? Okay, no, it will reduced to 50%, means it become R naught by 2. So final concentration is nothing but R naught by 2. Okay, 50% is consumed, so final concentration will get R naught by 2. Okay, that is the 50% will remain. Okay, so substitute this value. K is equal to what, initial concentration is R naught minus final concentration is nothing but R naught by 2 divided by time is nothing but T half or T 50% we can write. Okay, see 1 minus half is what, half, so we can write K is equal to R naught by 2. So 2 will come to the denominator, so 2 you can write down, okay, into T half. So from here we can write T half, you move to the left hand side, K you move to the right hand side. So we can write T half is equal to R naught divided by 2K. Okay, this is the derivation for T half for zero order reaction. What we have to remember that T half is directly proportional to the initial concentration. This graph is very important. You should, how can we plot the graph? Let's see, we can plot the graph like this. So here T half is there, and this side is what, initial concentration is there. So it is directly proportional. Directly proportional means graph will go straight line like this. Okay, T half versus R naught. Okay, so T half is nothing but R naught by 2K. I hope you understood these two concepts, expression of K for zero order reaction and T half for zero order reaction. Please like the videos and subscribe the channel. Also share with your friends. Thank you.